Hello, in this example we're going to take a look at how to run a simulation study of an assembly involving small displacement contact. Here we have a simple three-part assembly of a shaft and two bearings. Now the shaft is ideally fit in between the two bearings, and one thing that you always want to do before you run an analysis like this is use the SOLIDWORKS interference detection tool to find out whether or not you have any actual interferences. When I run the interference detection tool, a very useful setting is this one that says treat coincidence as interference. This will help me, number one, identify if I have any interferences, but it will also identify any touching faces. After I run the interference check, it shows me two coincident interferences. So what I learned from this is, first off, I do not have any actual interferences. And that is good, because if I have interferences, that will affect the mesher and it may impede my ability to solve a problem. However, these interferences are just coincident only. So I have two sets of touching faces to concern myself with in my simulation study. Let's now build a new static simulation study. First thing I need to do is assign material to my parts. I can assign materials individually, or if all the parts are of the same material, I can just right-click and apply material to all. I'll choose the 304 steel. All parts now have that material. We now can apply some fixtures. I'll use a fixed geometry restraint on the bottom of each of the bearings. One thing that I'd like to do a lot of times is to hide my fixture symbols just by right-clicking and choosing the hide option. Let's apply a couple of external loads. I'll put a force downward on the end of my shaft, 200 newtons, and I'll also put a side load at this end of 150 newtons. Once again, I can hide those symbols just by right-clicking on them in the assembly or in the Analysis Manager tree and choosing the hide option. Now we need to define how the contact will be handled between those touching face sets. By default, whenever I have an assembly, SOLIDWORKS creates a global contact condition, and the default is generally set to bonded, which means any parts that are touching any other parts will be treated as bonded, unless you have any local contact sets that have been defined. In our case, I'd like to define local contact sets that will maintain contact for the shaft to the bearings, but will allow them to separate if the loads become significant enough. This can be done easily using the connections command to define a contact set. In the contact set command, I can either manually define contact sets by matching up pairs of faces that I expect to come into contact or want to be able to contact or separate, or I can have SOLIDWORKS automatically find those contact sets based on just picking on the components I want it to check for. When I choose Find Faces, it determines that there are two contact sets, and these are the exact two contact sets that I found when I ran my interference detection. I'll have SOLIDWORKS set those to a no penetration contact. This means that SOLIDWORKS will monitor the contact between those faces, and they, depending on the loads, they may separate from each other. Once I've defined my contact sets, I'm now ready to mesh the model, and I'll just accept the default mesh, which will be fairly coarse for these purposes, but probably good to get us an initial guess or set a baseline. Now with this coarse mesh, I can simply begin to run my analysis. Keep in mind, whenever you run an analysis involving no penetration contact, you can expect the run times to be longer than for just a simple model with bonded contact. With that in mind, I've already run the analysis in the background and have that stored in another study. Let's review the results. When I go to my von Mises stress plot, I've set up a section plot, and I have applied a displacement, a scaling of around 250 to really exaggerate the deformed shape. When I zoom in on a side view and attempt to animate this plot by right-click and choose Animate, we should now see how the shaft is bending down, and you can see how loads are being transferred through contact from one part to the other. And if we zoom in really close, you can see how the shaft is actually separating ever so slightly from the upper bearing. Because the displacements are very small, we've had to exaggerate our results in order to see that. An additional plot that I've created is my displacement plot, which shows the mesh superimposed on my model. And once again, if I animate this plot, we can see that indeed there is some separation going on. And that is by virtue of the no penetration contacts, which are allowing the contacting parts to separate based on the loads that are applied. So there's a simple example using the no penetration contact.